This is the cassette tutorial for the tape disc system, the basic teacher. Alright, to begin, we need to open up the drive and insert the disc entitled the basic teacher. If the computer is turned on, then we need to type and input PR, the number sign which is over the 3, 6, and touch return. If the computer was turned off, it's simpler just to go ahead and put the disk in the drive and turn the computer on, and it'll auto start if you have an Apple II Plus or a 2E. Alright, now on the screen you should see the basic teacher, copyright 1984 by Adrian Vance, and you're asked the question instructions, Y or N. And you'll see this a lot. It means simply touch Y or touch N. So let's touch Y. This program system will teach you the fundamentals of AppleSoft Basic by example. We have analyzed the language into 7 statement groups. Run each program, then make changes as shown in the manual. Type input run BT to return to the main program. Okay, now touch key. The drive runs again. Now we're actually at the main menu, and you're asked the question, in which area would you prefer to work? And here we have 7. We have output statements, math statements, string statements, machine statements, program statements, graphics statements, and Boolean statements. Touch key of choice. Okay, this is a progressive system. We've designed it to work from front to back, and I would like you to start with output statements, so let's touch key number A. Okay, then the first of our sub-menus flashes on the screen, the A series, the output statements. And we have 12 of them. They include print, is number 1. Then we have home, tab, inverse, flash, normal, H-tab, V-tab, pause, POS, speed, SPC for space, and text. Okay, let's start with number 1. So we'll touch number 1. Now this time you'll notice that after you've touched the key, nothing happens. The reason for that is that in the previous choices we were using what is called the get command, and with the get command you only need to touch 1 key. In this case, where we have 12 choices, from 10 on up, we need to touch 2 keys, 1 and 0, 1 and 1, or 1 and 2. So we cannot use the get command. We have to use the input command, and then that requires that once you've made the number input, you then have to touch return. So after we've touched number 1, and 1 will appear on the screen, let's go on and touch return, and the drive will run again, and this will give us the first of our programs. Now this is a very simple program. As I said, we're beginning at the beginning, and we will see first of all the output of the program on the screen, then a listing of the program starting with number 10 and running through number 50. Okay, the output includes words in quotes, the number 4, and name. Alright, notice in line number 10, the first thing we see is home, and that is simply a command or a statement that puts the cursor in the upper left-hand corner of the screen to begin outputting. The colon in BASIC is the same thing as a period in our normal English language. NA $sign is the string variable, and we're calling that, we're saying that is equal to NAME. Anything we put in quotes in this fashion will equal that symbol, NA $sign. Okay, then in line 20 we say print words in quotes. We have those between the quotation marks, and so they appear on the screen. Now notice that words in quotes appears at the top of the screen. Then we have the number 4, where in line 30 we've said print 2 times 2. Then we have name under that, where it's printed NA$. List simply means that the program that ran will be listed below, and we see it, of course, on the screen. All right, now here's what I would like you to do. I would like you to stop and make some changes in this program. I would like you to change line 20, and I would like you to type print, quote, anything you wish to say, and then another quotation mark. I'd like you to change in line 30 to say print 2 times 4, and you'll notice that we use the asterisk or star as the multiplication sign. I would like you to make a change in line 10. Remember to include home, colon, then $, equals, and between the quotation marks, put in your own name. Make experiments and changes in this program and every program that we work with in this entire series. Now, there are 98 of these programs, so you have a bit of typing to do, but not so much as if you copy these out of a book. But make changes in these things, and as we go through and work together, either with the manual or with the tape, you'll see the critical areas where we want to make the changes so that we can see what happens, and you will learn the language very quickly by doing this. Okay, now I'd like you to stop the machine, make all of these changes, and experiment with this program until you really feel very good about everything that's in it, especially the word print. That's the reason that we access this program in the first place. Then, when you're finished, just type and input run, R-U-N-B-T, and that will take you back to the menu, and we can continue on to the next program from there. Okay, now you're finished with that program, and incidentally, at any time you wish, you can always type and run BT and get the original program that you've been working with back on the screen. So now let's just type run BT. Okay, and we see the main menu again, so let's touch A again. Now, this time let's type in input number 2 for home. Actually, we already know what home does, but we'll just take a look at the program. Home sends the cursor to the top left corner of the screen. Delete line 10 by type inputting 10. Then type input run to see what happens without it. Okay, let's do that. We just type 10 and touch return. That erases the home in line 10. Okay, now let's type run, R-U-N, and we see that the program runs and is listed underneath. Now let's put line 10 back in again. We'll type 10 and type H-O-M-E. Okay, now let's type run. There we go, and it's back to the way it was. Okay, now this time rather than typing run BT, let's access the next program directly. Now let me show you what's on this disk. First of all, let's type catalog, C-A-T-A-L-O-G, and then touch return. Okay, now you'll see AV Systems Inc., and under that you'll see hello. Directly under that, now the hello program was responsible for the very first thing you saw on the screen. Directly under that is the main menu program, which we've labeled BT. Okay, and then under that you'll see A1, A2, A3, and so on and so forth. Alright, these are all the A series programs. Let's touch the space bar and you'll see some more programs. Now we see the B and the beginning of the C series programs down to C2 on my screen. Okay, and touching the spacebar again gives us, we're well into the D series and the E series and the F series. Now you'll see a couple of odd ones here. There's a B program with 34 sectors with a label PIC.HGR2. That is a picture, and we'll get to that toward the end of our study. And then just below that there's a little short one called ST. That is a shape table. And again, we'll get to those when we study the graphics. Okay, we have 100 programs on this disk altogether. They're very short, most of them, and you can access them directly by just typing, as we're going to now, run R-U-N, A3. See, we've already run A1. We've run A2. Now let's run A3. All right, now we're asked to type input a number from 1 to 35. Let's begin at the beginning. Let's type input 1. Okay, tab 1. Program A3 is the program that has to do with the statement tab. Now, as I said, we can access these programs directly, and that's the instruction that you're given when you work with the manual. If you're working with the cassette, or you're working without the cassette, which you can do, just work with the disc directly, the thing to do always is to type input run BT. Now, it's a little bit troublesome. It takes you back to that main menu continually, but this way, when you navigate through this entire system, you'll have some concept of where you are. If you're working with the manual, the fastest way to do it as you read the manual is to just type and then input A3, A4, A5, A6, and so on through the whole business. But there, when you're reading the manual, you have a lot of guidance and many words, and you know where you are. Working with the cassette alone, you tend to get a little bit lost because you don't have a visual input of what it is you're working about. So always type input run BT. Now, in this particular program, we want to run this several times. Let's run it again now. We'll just type run. Okay. Type input a number from 1 to 35. Let's input number 10. Okay, do you see how the output has moved? Originally, tab was way over at the left at the first position. Now it has moved, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, what do you know, 10. Okay, if you study the program, line 20 is really the critical line. Print tab, and then you'll notice the enclosure N. Now, N was the number that we input in line 10. You see the semicolon, colon, input N. Okay, when we input the number 10, then N became 10. Then the output tab, and then a semicolon N, and it has printed up here tab 10. That was the number N. Okay, tab is a very important function for moving type one way and another across the screen, and you can see how it works if you run this program a few times. Let's run it again, and we'll input 20. Okay, well, number 20. Very good. And if you count all of those spaces, you'll find that the output begins at position number 20. Okay, now this computer is operating in normal mode of 40 columns, the 40-column screen. That is, there are 40 positions from one side to the other. In this particular program, we've asked you not to exceed number 35 because the TAB space number will push it all the way over. In fact, let's just do that so you can see what the effect is. We'll type input run again, then we'll input 35, and you'll see that the entire output is all the way over to the right. The farthest we can go with this is up to 39 because the spaces on the screen are actually numbered from 0 to 39. This is one thing you have to learn about working with computers, and it's a little disconcerting at first, but in our normal experience, we don't work with 0 that much, but in computers, everything starts with 0. It's the first number. And that's an extremely important concept. You'll notice that inside the Apple, the slots are numbered from 0 to 7. When you begin to work with bytes, you'll learn that the first bit is numbered 0 and the last one is 7. You just have to get used to the fact that computers use 0. Okay, now let's type input run BT and return to the main menu. Run BT, okay? And we touch return, and away the drive goes, and we'll soon be back to the main menu. Okay, now, output statements, let's go back to A. Okay, this is what I would like you to do because we're running out of time here much faster than I had expected. I'd like you to go through and work with each of these functions, inverse, flash, and normal. These things are all related together, and your understanding of them should happen very quickly. H tab, horizontal tab, of course, places things horizontally on the screen. V-tab places things vertically. The position command tells you where something is located. Speed controls the output. Space inserts numbers of spaces between text. And text actually is a statement that causes the computer to read a certain section of the memory, whereas when we are dealing with graphics, either in low res or high res, the machine reads other sections of the memory. Text brings us back to the text part of the memory, and then that's what we're seeing output on the screen. Actually, what you're looking at on the screen is just a bunch of dots as far as the computer is concerned. It's a bunch of dots that happen to be organized in a way that we're used to seeing letters. And each one of these letters consists of 56 dots, or, well, if there were 56, it would just be a big square. But it consists of a great number of dots that are each one of these is a little bit in the memory. Okay, now I want you to work through this entire section, and after you have finished this section, I would like you to restart the tape. I want you to stop the tape and go through all of these parts in here, and then come back to the tape when you're ready to go on to the B series. Okay, now we're ready to do the B series. These are the math statements. So let's touch B. And here we see a screen quite filled with material. All right, number 1 is the multiplication operator. This is actually not a statement, but it's an operator. And it is the asterisk or star. Number 2 is for subtraction, and that is the minus sign. Number 3 is division. Number 4 is addition. Number 5 is absolute value. That will give us, that can be important in certain kinds of equations. Now, the way you will get on with this section of the system will depend very much on how much training you've had in mathematics. If you've had a lot of mathematics training and you understand a lot of these things, the trig functions, for example, 10, 11, 12, and 13, then that will all come very naturally. You'll see applications for it, and it'll make a great deal of sense. If you're not very well trained in mathematics, then that will be confusing only because the subject matter itself is confusing. In number 6, we have the random order function. This generates a random order number, and this can be a very interesting function in giving us programs that appear to change. In other words, we can ask for a random number, and based on that random number, we can have the program pointer go to different places and make different choices so that every time we run the program, we get a different output. The SGN, or sign function, tells us the sign of a number. That's number 7. Number 8 gives us the square. Number 9, define function, is a very important statement to work with if you're working with a very complicated program system, because what this enables you to do is to define a certain operation. It can be a mathematical mess, and you can have it very neatly written in one function, and then you can go back in the program whenever you wish and you can access that function. So it really gives you the power of sort of rewriting the mathematical language within the computer, because what you do is you define a function, and then you can just go after that function again and again and again. You don't have to keep rewriting it and rewriting it and rewriting it. It's a very economical capability to have. Okay, and as I said, 10, 11, 12, and 13 are the trigonometric functions, the sine, the tangent, the cosine. And the arctangent is actually gives you the angle for a particular tangent. And one thing you have to remember, and this all of the mathematicians, those who have had some math anyway, will understand, all of these trig functions are done in radians, and you have to remember that, because you will probably, as I did when I first started this, begin to work in degrees, and that doesn't work. So in those programs in that section, we keep pointing out again and again that everything has to be in radians, and there are 2 pi radians in a circle, and that system is one that's used universally, and it is one that's very convenient for computers to deal with, and that's the reason that it is used. Number 14 is interesting, let, because in AppleSoft Basic we don't use it. It's unnecessary. If you see a program in AppleSoft Basic that includes let, you're probably reading a program that's been written by someone who has come from another computer, and they're just falling back on old habits. All this accomplishes is using up bytes that are unnecessarily consumed, and we just don't use it. Int will give you the integer for a number, dropping off anything beyond the decimal point and just simply reporting the figures to the left of the decimal point. Exponent and log, of course, are related to exponential functions. Read, data, and restore are the three related statements here, dealing with having data within the program, the body of the program itself, reading that data and operating with it. And then restore allows us to reuse the data a second time, because reading the data normally leaves the data pointer at the end of that particular data batch. And so if we go back and try to use it again, the pointer sort of just falls off the cliff. Well, we don't like that to happen, so we invoke the restore statement, and that causes that particular data pointer to go to the head of that file, and then the data is accessible again. That's a very important feature. Less than, more than, and not equal to, I'm sure most of you are familiar with. These are very easy signs to use. They are very important because they allow us to make choices within equations. It permits us to examine outputs in terms of whether or not they are less than or more than a certain threshold figure or whatever, and it gives us a very important power within within a particular program. Okay, now I would like you to begin at the beginning with number 1, and let's type number 1, and then touch return, and the drive will run. And I would like you to study this program. Now, this is very important. Whenever you're working with any of these programs, make changes in them. Go through and let's change line 20 to say print 2 times 4 or whatever. Now, of course, here we're using the variables in line 10, A, B, and C. Okay? Make a change after you've run this a few times with other changes. Make a change in here. Let's go back and type 10, home, colon, A equals 14, B equals 57, C equals 98, and see what happens. Then run the program. If at any time you make a mistake in a change and the whole thing is just all messed up, it is a very simple thing to go back and type run BT, get the original program back, and you can start over again. Now that's the beauty of this system, and that was the main reason that we developed it, because we wanted to have something that would permit you to learn BASIC on the computer, to move very quickly through it, not to be penalized for the normal mistakes that we all make in doing this kind of thing, and to be able to get that original program back very quickly, and also to have the program run and be displayed in a manner that was convenient to you. So you'll notice in working with all of these, as you probably have in the first section, that all of these programs are presented to you in a way, they're all very short. They've been organized in a manner that will present them on the screen as a single page so that you're not having to step through with Control S or whatever. And the thing is meant for your convenience. So I would like you to work through this entire series, all of the mathematics functions. If you are not a mathematician and you have no use for the trig functions, I would like you at least to work with them a little bit so that you have some familiarity with them. And if you don't plan to use them, then just go on and don't be concerned about it. When the time comes, trigonometry is really quite easy if you're using it, if you've got a use for it. And trigonometry is abysmally hard if you have no use for it and you just got to learn it and get a grade. But if you have no use for certain of these things, like the trig functions especially, or square or whatever, then skip over it and go on. The random order function, I think, is very important in many kinds of programming downstream, and that's something that you really should be familiar with. It's a function that generates choice, and the computer appears to choose things, and that'll give it a very interesting kind of output and can make certain programs that you'll be doing very lively and interesting. Okay, so let's go through these all the way through the entire list, one at a time, and then after you've finished, come back to the cassette and we'll go on to the next batch. Okay, now we're ready to do string functions. And string functions are really a very important part of computing. String functions permit us to work with words. And immediately at the beginning you'll see left dollar, mid dollar, and right dollar. Now every time we see the dollar sign connected to a word like this, it means that the word is a statement for a string function, that it works with a word. And it'll work, the words are normally enclosed in quotation marks, and left dollar will work with the left portion of a word, mid dollar will work with the middle portion of the word, and that middle portion can be 1, 2, 3, 4, or any large number of letters. Right dollar, of course, means that it's working with the right portion of a word. A string in AppleSoft BASIC can be up to 255 letters, and it can include numbers, long. But normally a string will only be about 5 letters long. That's the length of the average English word. Okay, get, we had talked about before at the very beginning. This is the statement that makes it stop and wait for one letter or number to be input. Dimension is a statement that we use for reserving space in the memory. Len, for length, tells us the length of a particular string, whether it's 1 or 5 or 40 or 255 characters long. Now here again we see read, data, and restore. Read, data, and restore work both in math functions with numbers, with numeric variables, and also with strings. If we define the data as a series of strings in quotation marks separated by commas, as you'll see when you work with that, then we can do all of these things that in a very similar fashion to that which we can do with numbers. Well, we can't add and subtract them, but we can search the data, we can use it in varieties of ways, and that's very important. And also restore, again, permits us to access that data after having used it once, and we can go back again and again and again. ASC gives us the ASCII number for a particular letter, or if you have a string that has more than one letter, it'll give you the ASCII code for the ASCII number in decimal for the first letter of that string. Val will convert a numeric string to a numeric value. And number 12, control dollar, lets us communicate directly with the machine. When we touch the A key, for example, what we're really inputting is a number 65, and we don't see the number 65 on the screen, we see the letter A. And of course there are 256 possible control codes, and so in using the alphabet we're only working with 26 of them, but by using control dollar we can work with all of the possible codes directly. String dollar, number 13, will convert a number into a string. We have to translate back and forth from time to time from strings to numbers to operate equations and to have outputs on the screen, and we also do that for error trapping, and there are just numbers of ways which you will see demonstrated in this program and other programs in the series on how we can use these various functions. Now, one thing when you study this area I want you to be aware of, none of these things are isolated. They're all working together. When you work with left dollar, mid dollar, right dollar, you'll be working with a certain kind of function, but you'll also be working with other parts of the language. It's important to do two things. Find the function that you're working with within that program and isolate what it's doing and work with that, but also be aware of what's happening around it, because all of these things work in the context of the basic language. Okay, now I'd like you to go ahead and work through these. Start with number 1, work through the entire series, and then when you're finished, turn on the tape recorder again. But for now, just stop the tape and go to work on these functions. Okay, in the D series machine statements we have 16, and they start out with PR number and IN number. These two are virtually identical. PR is an outputting command, and IN, of course, is an inputting command. PDL, number 3, has to do with the game controls, which are called paddles, and there are normally 2 of them, but the connector, interestingly enough, actually has channels for 4, and this can be a very important inputting or outputting device. It permits us to make lots and lots of different kinds of connections to the computer, and it's something which up to the present time has been rather underused, and I think it's something that you should understand, especially if you're interested in applications as in chemistry and physics, where you want to use the computer to do things for you. This is one area where a little study can give you a lot of ideas. USR is a function that transfers information to a machine language subroutine. And call, which is number 5, transfers control from BASIC to an assembly language program or a subroutine that is resident in the computer. We have a number of these, and in the call program you'll be presented with a number of the ones that we have, like call, -936, and so forth. They're very interesting. Okay, now it is time to turn the tape. Peek permits you to look in the memory and see what is stored there. Poke permits you to put things into the memory, and this is a very tricky. If you start poking around the computer in a rather random fashion, you'll soon have a machine that will crash on you. But what's nice about it, the damage that you can do with poke, and this is the only statement that we have or command that you can use from the keyboard where you can actually do some damage. The only damage that you can do will be repaired by simply rebooting the disk or reaccessing the program that was running. Pop is a statement that causes the last address to be popped off of the stack, which is a short-term memory for the computer, and if you're using go sub and return, which is something we'll get into in the next section, pop will permit you to exit from a go sub return without having an error downstream when you use another go sub return. But that here again is a little messy, and you'll have to see that in context, and it's probably something that you won't use for a long time. Now we get to the interesting situation where we have some stuff that we don't use, but you should know about it. Load, save, store, recall, shload. These are all terms that are used in cassette operation. When the Apple computer was originally released, there was not a disk drive for it, and so the inventors, the developers of the computer, had a cassette operating system built into the language, and that's what these 5 commands here are for. Load will load a program from cassette, save will save a program to cassette, store will store an array to a cassette, recall will recall that array from a cassette, shload is for loading a shape table. Now, these 5 things are not used. I do want you to work with them enough that you understand what they do and how they operate, and they're all very simple and straightforward. Because on occasion, somebody will come up with some new kind of fantastic machine or whatever that will use this sort of technology, and I have no idea what it'll be, but I think we should be aware of it and not forget it, but these things are things that you will probably never use. Number 14, FRE, will tell you, well, it does 2 things. It'll tell you how much memory is available, but also used in a program, it will house clean the variables. A computer is rather like some of the teachers that you've had that write on every blackboard until the whole thing is full, and then they stand back and look at it, and maybe they'll have a student erase it. That's the way a computer works. It just writes on all the available space, and then finally, when all of the space is gone, it'll house clean. Now this is the occasion, and when you're new to computers and you don't know about this, you'll be running a big program and then all at once it'll stop. And you'll think something has gone terribly wrong. Well, all that's happening is that the thing is cleaning up itself. It's erasing the blackboard, so to speak, and so that it can go on and then write in all of them again. High mem and low mem, numbers 15 and 16, are statements that we have to use normally in graphics programming to reserve sections of the memory to be sure that the computer doesn't start writing some variable information on the graphics page that we're trying to see on the screen. When that happens, as it undoubtedly will when you begin to work in graphic programming, if you forget to set the memory correctly, you'll see a line of dots and strange things begin to appear on a picture. And this is very disconcerting, and sometimes it's very hard to cure because you'll be working with a large program, let's say something that has a lot of mathematical or financial operations in it. It's going to output a chart, so that needs a big section of memory. You've got all kinds of data that you've loaded from a disk into it, so that's used all kinds of memory. Sometimes there just isn't a good place to put anything, and so if you don't have the low mem and high mem statements set correctly, the computer will start writing it on the picture page, and there you go. So we have to work with these carefully, and usually when you're concerned with these and working with them, you also have a lot of other things going, so it can be messy. But we show you examples of how these work in routines 15 and 16, and I think you'll get on with them rather well. Now, this is what I would like you to do, again as we did before. Start at number 1 with PR, work with that program, and go right through the series from beginning to end, and then when you're finished, come back to the tape and we'll talk about the next series. Okay, now we're ready to do the program statements, choice E. And here we see 16 more, and these, most of them are quite simple, and in fact most of them you've done some work with already. For example, run, number 1, you've used many times. You've seen end a few times, and you've seen list many times. Okay, now stop is a very important statement that we use when we're developing programs. You can drop stop in to a place and you can make the program run up to that point and then it'll quit. And the reason for doing that is that you found that you have a problem, and so what you do is you drop stop in to find exactly where the problem is located and where things are going wrong, and you just keep moving it and moving it and moving it, and you have to take it out every time you put it in, or else the program will just simply stop there. End is not needed in short AppleSoft programs, and we have not had end on most of these programs simply because we wanted to conserve screen space and we wanted to put as little on the screen as possible. But when you start working with and writing longer AppleSoft programs, you'll find that you have to have end, and not very much longer really, because often the program will end not at the very end of the listing, but somewhere in the middle, because at the end of the listing you have error routines, you have data, and one thing and another, and if you don't end the program at a certain point, then the program pointer will just run right through the data and so forth, and you'll see all this garbage on the screen, and there will be error messages and bells will be ringing and so forth, and you won't know what's happening. Rem is probably the most important word in BASIC, believe me. Rem permits you to write something within the program that will label something, that will explain a routine, that will define variables or whatever. Beginning BASIC programmers are usually over-concerned about the length of a program and about how fast the program will run. And what happens is that they normally omit rem statements where they should be putting them. And then when they come back to the program later, they don't know what something or the other means. Well, that's a very bad situation, and it can be easily rectified by dropping in the REM statements, by keeping very accurate notes on all the programs you're doing, and by just saving a lot of paper. You use an amazing amount of paper when you're developing a software package, and really what you should do every time you pick up a piece of paper and start to work with it is to put the date on it and punch 3 holes in it if it doesn't have them already, and stick it in a notebook and hang on to it, because there are times when your mind will begin to wander in other directions and you will forget about some very neat little trick that you've developed, and you try to remember what it is and you'll spend a day going back to it. Things like REM, where we document what we've been doing, are extremely important, and it should be used again and again and again. When you get your program that you're developing finished and you want to knock the REM statements out, there are many program editing programs that will take them out automatically, that will compact the program and make it run lickety-split. So don't worry about adding REM. Actually, you can run some tests with it, and I have. Adding a lot of REM statements really doesn't increase the processing time appreciably unless you just have hundreds of them, and you have to have them in a certain way. But really, what happens is that the program pointer just skips over them. It goes, and so it just doesn't cost anything in terms of time, and the space for most programmers is just really unimportant. Okay, del, number 5, is the delete statement, and it permits us to delete certain lines of programs. We can say del. Now you have to have 2. You'll say del 20 to 50, or del 110 to 180. You cannot just delete one line. If you want to do that, the thing to do is just to put the line number up and then hit return, and the line will be deleted. New erases everything in the program, and this is a statement or a command that we issue from the keyboard with caution. Clear will clear the variables, and this is a statement that we unfortunately cannot use very often, because normally if you want to exit a program, there's no reason to bother to clear the variables. That'll be done automatically when the new program is installed. If you want to run the program again, normally you'll want to save something. But in those cases where you don't want to save anything, you can use clear, and it'll clear all the variables, and then you can run the program again. List, of course, we've talked about and you've seen many times. Wait is a statement that in AppleSoft Basic does not mean what it does in some of the other versions of Basic. Wait in some versions of Basic is a timer. You can say wait 1 and the program will wait 1 second. That is not the way it works in Basic. In AppleSoft Basic, you'll have to pay close attention to this program to see what it does. In AppleSoft Basic, wait normally is only used to test for a certain keyboard condition, i.e. has somebody touched a certain key, and that's what the example program shows you. Wait doesn't get used very much by AppleSoft Basic programmers because we have other ways of going about it, either get, which is used very frequently, or reading certain peaks and so forth. So wait just waits. On error resume is an error routine, and this is very important when you begin to develop fairly large programs where there might be errors. You can have error routines, and on error resume is the main statement combination that you use to make error routines work. Input we have used many times before in context, and of course this causes the program pointer to wait until something comes from the keyboard via return, not just a single touch of a key, but maybe 1, 2, 3, 4, whatever, and then you touch return and the input is actually made. If then is a conditional test which will cause the program pointer to jump to a location depending on whether or not it qualifies. On go to is a very interesting automatic branching routine. Go to is an unconditional test which will cause the program pointer simply to jump to a new location. Go to line 100, go to 1000, go to wherever it'll go. No qualification is needed. Trace and no trace are used together in tracing what's going on in a program. Usually when you're working with this, you have a program that's in trouble. The one unfortunate thing about trace is that it will not work with a disk operating system. If you use trace, the disk drive will not operate, it won't load data or whatever. So what you have to do is to place trace in a place where the disk has already loaded whatever data or whatever you need. Then you invoke trace, follow what happens, and then a very good way to use it is to then follow it with no trace a few lines downstream, because if you just use trace and you run a program with trace in operation, the screen will soon be filled with all this stuff and you won't know one number from another because they're just running all over the place. So trace and no trace have to be used in combination, and also it's necessary to use no trace with trace because nothing shuts it off. If you invoke trace and you try to go to another program, you'll see the thing is still in operation. So the two are used together. Go sub and return is our main subroutine statement combination, and here we're able to send the program pointer out of a routine downstream or upstream someplace to pick up something, and after it has done an operation there, the next line or even the end of the line will say return, and it'll go back from where it came. Go sub and return are very important to programmers that want to save space and use certain routines over and over again. The go sub return combination will drive you crazy if you're trying to analyze somebody else's program, because there isn't a label with it. It just says, it'll say go sub wherever. Okay, you go there, and then if you don't know where you come from, when you see the return, you don't know where it's returning to. It doesn't say return, to line 40 or return to line 100, or it just says return. Well, return where? Well, then you have to find where it came from. So this causes some very big problems if you're trying to figure out what somebody else has done in a program. Okay, now I want you to work with these program statements again, starting with number 1, and just work your way through very carefully. These are a little more complicated than some of the things you've seen, and you have to work with them carefully and make changes and do things with them, and then you'll begin to understand them. And as soon as you've finished with these, then return to the tape and we'll continue on to the next series. Okay, now we're ready to do the graphic statements. Choice F. Alright, now these are broken into two batches. The upper part of the screen, 1 through 6, deals with low-res graphics programming, and the lower portion of the screen from 7 through 14 deals with high-res. These are two very different areas of graphics programming, but they are still graphic statements, and we need to learn them together. Okay, number 1, GR, sets the computer into the graphics mode. Now really all this does is output a different section of the memory to the screen than that which we've been looking at in the text mode. Plot plots points in the low-res graphics mode, and the point or dot is actually a small rectangle. Screen tells you what color is at a particular point, and this is a low-res graphics statement that really doesn't get used very much, but it's there. It gives us a chance to get some information from the screen. There are 16 colors that are available in low-res graphics, and it's possible with color coding, I suppose, to make some use of that. I've not seen that done ever that I can think of, but anyway, again, the potential is there. Perhaps there's some application you may think of, and you can use it. H-line and V-line are important in low-res programming because they give us a certain economy. We can draw long lines. Instead of having to plot lots of dots, we can just plot these lines and fill up a figure very quickly. Color, the equal sign goes with it, and the colors range from number 0 to number 15. Again, in computing, we use the number 0. Okay, in the high-res section, we have HGR, which again, like GR, outputs yet another area to the screen. And this area of the memory is from 8192 to 16384. 8,192 bytes worth. Okay, that's a lot of memory, but that's what it takes to make a picture. HGR2 outputs yet another area of the memory to the screen. H-color in high-res programming sets the color. And in high-res programming, there are really, well, it depends a lot on the color monitor, but there are supposed to be 7 or 8 colors, and actually it comes down to about 4 that you can really use. Okay, draw is for drawing a shape. Now, a shape is a little table of information about a little figure. Actually, all of these letters that we see on the screen are really shapes, and it's a combination, a series of dots in lines and circles and so forth to make the various figures that we see on the screen, and they're labeled shape 1, shape 2, shape 3, shape 4 on through whatever. And if we set up shape tables, for example, for the alphabet, we would have shape 1, let's say, would be A, and shape 26 would be Z. And if we would say draw 1 at a certain number on the screen and another number, we would see the letter A at that location. Now, XDraw operates exactly the same way except for one thing. XDraw draws the complementary color of whatever is at that screen location at that particular location. Okay, now this may sound a little strange. Why would anyone want to do that? Think about it for a minute. If it draws the complementary color of whatever is there, suppose nothing is there or black is on the screen, it'll draw white. Okay, but then suppose we come back and we say XDraw that same figure again. Well, now this time white is there, so it draws black. All right, it erases it. XDraw can be thought of as our animation command. It permits us to draw and erase in a single command by simply using that same command over and over again to draw and erase figures. And when we want to animate something, if we want to make a little man walk across the screen, we've got 2 or 3 figures we work with, and you XDraw, okay? And what you're doing is drawing and erasing, drawing and erasing, drawing and erasing, and moving in between. And that's how it works. And it's a very neat command, and it's one that you'll enjoy working with a lot. Hplot will put lines. Well, you start with a dot. First of all, you say hplot at 4040. And then you say hplot to 40/100. And zap, there goes the line. Scale sets the size of a shape. And for any of these shape drawing routines, or where you're using draw or XDraw, you need to set the scale. Now, if you haven't set the scale will automatically default to 1. But if you want to change the size of a figure and make it appear to come close, then you change the scale. Change the scale from 1 to 2 to 3 to 4 to 5, and then it'll appear to, come toward you. Rotation, ROT, is the command that we use for making things spin or move around. Now, there are actually 64 positions that you can rotate, but if the figure is very, very small, if it's in the scale 1, it will only rotate in 4 of these. And you need to have a fairly large figure. In other words, if a very small figure is rotated, it'll usually only rotate 90 degrees. It'll go all the way over to 90 degrees, and then it'll be pointing down, and then it'll be pointing the other way, and then finally up again. And it only has 4 positions. But if you've got a fairly large figure and the scale is quite large, you can make it rotate very believably, and through 64 positions, which is quite a few. Okay, now I would like you to start, as we have before, with program number 1, GR, and let's just touch number 1 and then touch return and start out with the graphic programming. In the cases that we will see here, what we will do is first show you each of these programs, show you the listing, then we will show you what it does, and then when you touch the key again, you will then see the listing again. Now, in some cases where the screen will be completely full of material, we will not have an instruction on the screen. So please understand that you're meant then simply to touch any key, the space bar or any key on the keyboard, and you will then see the listing of the program so that you can then make changes in it or return to the menu. Okay, now continue from this point and work through. Now graphics programming is very complicated. It's the most complicated material you've seen yet. Please be patient with it and please make all the changes that are indicated in the manual. This is something that will take a little time to learn, but it's the most gratifying phase of all of this. When you're finished with this, then we'll continue to the very last thing. Okay, now we're ready for the last phase of this, the Boolean statement. So let's touch G. Okay, Boolean statements. There are only 3 of them, and, or, and not. And these are tricky, interesting, and very useful statements. They are not commands. They cannot be input directly from the keyboard and used in any direct fashion. They're rather subtle, and I think what we should do here is take a look at number 1. So let's touch number 1 and then touch return. And we'll go ahead. Okay, do you wish to continue? Well, maybe some of you will say no at this point, but let's say yes. Okay, now the program is listed. All right, now the key line here is in number 20, and this shows you how we use and. And it says, if a string is not equal to yes, and a string is not equal to no, or n, then 10. All right, line 20 is an error trap, and that is one of our primary uses of and. But more important than that, and is a qualifier. This is a situation rather like someone going to a supermarket trying to buy the right kind of breakfast food for the family. Suppose you've got one person that cannot stand Cheerios and somebody else doesn't like Corn Chex, but vice versa, they like the other kind. What do? Well, you buy Wheaties or some such, because they do not like, one doesn't like the other. This is an and situation. And this is how Boolean operators or Boolean statements work. They give us a very important tool in basic programming where we can add levels of qualification, or we can have universes that are imposed on others. And this is the reason that we've put them at the end, because we want you to have much of this fairly clearly in mind before you begin to work with these things, because this is the most subtle phase of the language, that part which deals with these sorts of choices. All right, now let's go on and let's run G2. This is the next program. And here again we see the same question. Do you wish to continue? Okay, let's say yes. All right, now here we have used or, and we've redefined the statement in line 20. A string equals yes, if A string equals yes, or if A string equals n, for no, then 40. Okay, if we've made the right choice, yes or no, then it's going to go to line 40. Otherwise, it'll go to line 10. Let's run the program again. RUN. Okay, do you wish to continue? Let's just hit D or any other key. See what happens? Nothing. The screen flashes. What's actually happening is that the thing is being erased and rewritten again. All right, now let's touch Y. Okay, this accomplishes the same thing using or, but it uses more lines. We have to have a line 30 go to 10, and it's not as economical as and was. That's one reason and is used so often in error traps. And this is what's very interesting. You can have if A is equal to Y and A is, or let's say A is not equal to Y and A is not equal to this and this and something else. And so you can string ands on until you've gone all the way through the 255 bytes that you can have in a single line, and even beyond by going to another line. But you can have ands and ands and ands and ands and ands, or you can have ors and ors and ors and ors and ors, and you can qualify inputs or data or whatever incredibly well. And that's how we use these things in programs. Okay, now let's run the very last one, not. So we'll run G3. All right, the first thing we see is input a number from 1 to 10. So let's input the number 1. The program runs and we see the listing, the number is less than 5. The key to, and the example for not, is in line 30. And line 30 reads, if not, bracket, n is less than 5, bracket, then 50. Right, now I want you to study this line, and you'll see that if not were not present, that the outcome would be exactly the opposite of what it is given that not is present. The simplest way to describe the function of not is that it's negative or contrary. And that can be very important. That can also be very confusing if you're not familiar with not and start to work with someone else's basic program and you see lots of nots sprinkled here and there. It can really be confusing. Okay, let's touch the key and go on to the next. It says touch Y. All right, let's go ahead with that and do it. And then we see you touched Y and the listing for the lines from 70 to 110. And here again in line 80 we have the critical line, if not, bracket A string equals quotation mark Y, then 100. Okay, we're just showing you here that not will also work with strings. Not is very often used with numeric variables, as in the previous example, but it'll also work with strings. Okay, let's touch the key and continue. Set flag F1 with 1 or 0. All right, let's set flag with 1. Now, let me talk about flags for a minute. Flags are very important in certain kinds of programs. We just developed an inventory control program, for example, recently, and one of the things that we had to deal with was the state sales tax. Well, it only applies in our case in California. So when the state of California is input in the information for the purchaser, we have to set a flag. So we set a flag in exactly the same way. Then when the printing is done, or when the amount is calculated in the invoice, it checks to see whether or not these flags have been set. Now you'll notice that we have labeled this flag F1, flag 1. Normally in our basic programs we'll have flags from 1 to 6, 7, or 8, and I have never had to use more than 9. In line 150, we check the flag. If not F1, then 180. The point of this is this. The program pointer will go one direction if the flag is 1, or it will go a different direction if the flag is 0. Now bear in mind that when you start with a basic program, all of the variables, all of the numeric variables, are automatically set to 0. So having this flag routine in here and checking for these flags is very economical, because all we do is set the flags from the previous position of 0. Now in some cases we may have to go back and reset a flag to 0 in order to get out of a certain area that the program has gone into, but that's a special case. But flags can be very important in constructing programs. This concludes your study of BASIC with the BASIC Teacher.